Okay, hi everybody. Um, what you're looking at here is a little device. It's a capacitor, and what it does is it stores energy that is not entirely used by inductive motors. Inductive motors are motors that have that draw electricity across coils and magnets, across coils to generate movement in magnets or vice versa. I'm not an electrical engineer, but basically what happens is the wave of electricity creates a magnetic flow that goes across the magnets that turns the motor and creates mechanical movement. Okay, basically what happens is this thing, all your inductive motors in your house, they draw a certain amount of energy to run those motors. Now, say your laundry machine, for example, it draws energy into the motor to turn or to tumble the dryer. Okay, all right, but you may have just a few items of clothes in the dryer, which means it doesn't really use much electricity. Versus you may have, a overfilled dryer, which it's going to need a little more energy to turn that drum. Okay, so the motor doesn't know what you're going to stick inside your laundry machine or your dryer, but it's rated to handle, a lot, just in case you put a lot in it. But what happens is, as it turns the drum, anything that isn't used just kind of gets either grounded out, or it turns into excess heat inside the motor and dissipates. Again, I'm not an electrical engineer, don't know how that works, but I didn't care. I just needed to know a general understanding of what's going on. I rate things by how much they work, and I look into the details, but I don't go all the way down to the nitty-gritty details, just because once I'm satisfied, I don't need to know everything. However, I need to know a lot, enough to make a decision, and in this case, basically what's happening is I learned that energy is becoming wasted. And so what this thing does here is, as that energy leaves, it goes into the inductive motor, it turns it, and then as whatever doesn't get used comes out the back end of it and leaves your system, your electrical system. However, this little device actually captures it and stores it. It's a capacitor, so it stores that leftover energy, and then as your inductive motor, say your dryer or what have you, is pulling new energy, the capacitor will release some of what it's holding back into the system. And so basically what it does is it recycles it in a loop. What isn't getting used gets funneled back into it on the front end. It pushes through whatever doesn't get used, comes out the back end, gets stored in this, and then released again in the front end. I'm sure you've seen the other videos on YouTube where they demonstrate, 5.7 amp motor is running, and he's drawing 5.7 from the city, and he's using 5.7, but then he flips the switch and turns this device on, and then all of a sudden, he's now only drawing 2.3, 2.4. Okay, so if you've watched that video, if you haven't watched that video, go watch that video. You'll learn a lot from that. It was very simple, basic concept. Again, I'm not an engineer, so I don't know the fundamentals of it, but again, I don't want to, and I don't need to. I just need to know that it works, and I need to know how to install it, and that's about it. I don't want to. I just want to get on with my life, but I want to save some money on my bills. Everybody wants to be green nowadays. Even, I don't care who you are. If you had a way to make it go green, if you could go green and it wasn't a pain in the butt, you would do it. So I thought, well, I'll put the little video together. I went through YouTube, found this. It's one of the names of these things is called Power Saver 1200, or there's different ranges, 32 or 3400 or whatever. Anyway, so after watching every damn video, staying up till 4 o'clock in the morning trying to find more about it, I found that nobody was going to tell me exactly how to install it. It turns out that it's extremely easy to install, and that's probably why no one shows you how to install it. They figure you figured it out for yourself. Perhaps inside that box is some instructions, but I didn't find anybody showing me how to install it, and I'm a visual kind of guy, so I thought, you know what, I'm going to go ahead and make myself a video. So if y'all ever want to know how to install this little gizmo, it's basically 3 wires that you hook up to your breaker box. 2 of them go into a breaker bar, a double pole with 30 amp breaker bar. The other one goes to the ground. Then, you know, obviously if you're smart, you'll turn off the entire power to your breaker box before you touch anything in there. And even after you've turned it off, I wouldn't go touching things you don't need to. I don't know enough to tell you whether there would or wouldn't be any excess leftover energy stored within the breaker box itself. But anyway, so I'm going to go ahead and show you how I would go about installing this thing, and we'll take it from there. You know, my theory is everybody wants to go green, but it's a pain in the butt. There's solar panels. Everybody, you know, you probably look at solar panels. You can make your own solar panels, but the bottom line is solar panel is going to make, you know, 3,700 watts a month. Wind, maybe you go to, you know, if you're looking wind, you're going to go to WindBlue. Maybe go to WindBlue's website. And very professional looking, but then you're going to eventually find your way to Missouri Wind and Power, which will have a lot more information on it. I advise you to go there, look at that if you're really interested in wind. That guy Jeff seems to know what he's doing. After comparing the 2 websites, his website is more handmade looking, whereas theirs looks like they hired a more professional designer to put it together. A little classier looking at WindBlue, but definitely more information over there at Jeff's site at Missouri Wind and Power. He's got a lot of videos to show you how to do things, and for me that's what counts. Jeff obviously knows what he's doing. He's got a little bit of attitude, but you know what? When you've got as many years of experience as him, and you see people get screwed left and right, you know what? I would be a little sarcastic, and I'd have a little bit of an attitude too. And then you got WindBlue out there, you know, encouraging people to make these little plastic PVC explode as soon as they get to like 50, 60 miles an hour. I mean, I don't know, WindBlue. Don't come sending me a bunch of emails, but I've been to your site, and you know, it was good, but in fact I found your site first, but for some reason your site didn't keep me away from Jeff's, and then I went to Jeff's. But anyways, after looking at wind and solar, I found that, wind's going to, you're going to have a turbine, $500 or $600. It's going to generate 40 kilowatts a month. Okay, I have a tiny little house. My house, I generate 1,100. This month was 1,112. So let's say 1,000 for me. It seems to be about normal in the summer. 1,000 kilowatts a month is what I need. Okay, well, shoot, if a wind turbine's only creating 40 kilowatts, I'm gonna have to have like 10, 12, I'm gonna have to army of those things up on my roof. Now, ideally, I guess you'd have a little solar going too, so you have 3 or 4 turbines and the rest solar. But solar panel, 200 watts, only gonna work 6 hours a day. You're looking at, $600-800. If you skimp around, you can find them cheaper, but $600 or $800 for a 200-watt solar panel. So you're looking at 37 kilowatts a month. That's less than a wind turbine. So the wind turbine is definitely the better way to go. Plus, it's generating power all day long. So if you're going to start a system, I would start with wind turbine, and then I'd move toward solar. Build your solar up slowly, gradually. But you still got battery banks and inverters, and I don't even want to get into the inverters. Modified sine inverters are going to be cheap, and you can get an 8,000 watt one from eBay for a few $100s. Real good deal there, but it's modified sine, so you're gonna have static in your and heat build up in your heat's gonna build up in your motors, and then you're gonna have static and popping and fizzing and stuff inside your stereo and TV and stuff. So the modified sine inverters are real good for running things that have heating elements. If you've got some kind of heating element going on in your water heater or your stove, you got an electric stove or something, modified sine's fine for that, because that's not picky. It burns it all up anyways. Light bulbs burns it up. Anything that burns up the electricity, modified sine's great. So I would recommend running the modified sine inverter on your 220